Assalamu alaikum students. Hope all of you are fine by the grace of Almighty Allah. In our today's video, we are going to talk about oxidation and reduction reactions. That means about redox reaction. And and we are going to start with magnesium plus oxygen gas produces magnesium oxide. It's in an oxidation reduction reaction or simply a redox reaction. Okay, electrons are being transferred from one element to another, and you have known that the oxidation number of any pure element is 0. Okay, here magnesium is a pure element and oxygen also. Okay, the oxidation number of any pure element is 0. And whenever the oxide, now in magnesium oxide, magnesium being an alkaline earth metal and group 2 elements, and that's why it has a charge of +2. Okay, and oxygen has a charge of -2. Okay, we know usually oxygen in any oxide use -2 oxidation state. Now notice that the oxidation state of magnesium went from 0 to +2. Okay, 0 to +2. So the oxidation state increased. Okay, the oxidation state increased from 0 to +2. And we know oxidation is loss of electron, and whenever the oxidation state goes up, oxidation is taking place. Okay, whenever the oxidation state goes up, oxidation is taking place, and the substance is said to be oxidized. So here magnesium is oxidized, and it loses electrons, and this is known as oxidation reaction. And the oxidation number decreased in case of oxygen. Okay, now in case of oxygen, the oxidation number decreased from 0 to -2. Okay, you can see here 0 to -2, and whenever the oxidation number decreases by gaining electron, that means the substance is being reduced. Okay, and that means oxygen is reduced, and it gains electron, and this is called reduction reaction. And now you need to remember that oxidation always occur with the loss of electrons, and a reduction is associated with the gain of electrons. And generally metals, they like to give away electrons. Okay, metals like to give away electrons, and they like to form metal cations. Okay, metal cations, as they give away electrons, they will acquire a positive charge. We have already known about that. Okay, and now non-metals like oxygen, and they like to acquire electrons. Okay, non-metals like oxygen, here non-metal is oxygen, and they like to acquire electrons, and so they will develop a negative charge, and the substance that is oxidized is known as to reducing agent. Very important term. Okay, the substance that is oxidized is known as to reducing agent or reductant, and the substance that is reduced is known as the oxidizing agent or oxidant. Okay, and metals are reducing agent because they will cause the other substance to be reduced. Okay, there the oxidizing agents are called oxidizing agent because they will cause the other substance to be oxidized but itself reduced. Okay, and metals are reducing agent. Here metal is, that means magnesium is reducing agent. Okay, and non-metals like oxygen, fluorine, etc., they are oxidizing agents because they cause another substance to be oxidized, and here oxygen is oxidizing agent. And these are some terms. These are some terms that you want to be familiar with when dealing with any type of redox reaction. Okay, and now let's back to the reaction. And now magnesium. Magnesium is changing into the magnesium ion, magnesium 2 plus ion. Okay, and this look at this reaction, and this magnesium ion has a plus 2 charge. In order to become plus 2 cation, it has to lose 2 electrons. Okay, the pure metal stellic magnesium has to lose 2 electrons to form a cation magnesium 2 plus or plus 2. And so now because magnesium lost electrons, this reaction is known as a oxidation half reaction. We know about that half reaction. Okay, this is the this is the oxidation part of the whole reaction. Okay, and now for oxygen I am going to write atomic oxygen. Okay, now I'm here we I take atomic oxygen, and because this reaction is not balanced. Okay, you can see this reaction is not balanced here, and individually oxygen acquires individually each oxygen acquires 2 electrons, and this reaction is known as a half reaction also, and this half reaction is known as reduction half reaction. Anytime when a substance loses electron, it is being oxidized. Okay, and this then the second half reaction is the reduction part, and the first half reaction is oxidation part. Since oxidation is acquiring electrons, it take part in reduction reaction, and whenever a substance gained electron, and if the oxidation number decreases, it's reduction. Here we can easily observe the oxidation state reduces. Okay, decreases, and that's why it's reduction part of the whole reaction, whole redox reaction. Now for half reactions, when you have an electron on the right side, this is an important concept for any half reactions. When anytime you have electrons on the right side, okay, it is going to be an oxidation half reaction. Okay, here you can see these electrons are in right side, and here whenever the electrons are on the left side, it is a reduction half reaction. Okay, you have to remember this is when you have to write the half reactions. And now consider this reaction. Okay, zinc metal, this is another reaction, and zinc metal reacts with hydrochloric acid to produce hydrogen gas and zinc chloride. Okay, zinc metal reacts with hydrochloric acid and then produce zinc chloride and hydrogen gas. This is a simple displacement reaction, single displacement reaction. Okay, and now identify the substance, that is we have to identify the substance that is oxidized and the substance that is reduced. Okay, and also identify the oxidizing agent and a reducing agent. Okay, I have already done this. Here you have to observe this and try to understand. Okay, now if you get a question like this is type on your test, on your exam, to find out a substance that is oxidized or reduced, always look at the reactants. Okay, always look at the reactant side. Okay, that means on the left side, in the left side, and because both the substance which is reduced or the substance which is oxidized, both are present in reactant side. Okay, reactants, and don't look at the products. Now let's find the oxidation states of everything. Let's you observe, I have already written the oxidation numbers above the elements, and now the oxidation state of any pure element is always 0. Okay, now for zinc, the oxidation state is 0. This is pure elemental zinc metal. And now whenever hydrogen is bonded with a non-metal, it's we know about that, it's going to have a +1 oxidation state. Okay, here you can see, here hydrogen is with chlorine. Chlorine is a non-metal, that's why it uses +1 oxidation state. And which means chlorine has to be -1. And we know from our rules, halogens are usually uses -1 oxidation state, except with oxygen. Okay, except with oxygen they use positive, they will use positive oxidation number. And so chlorine, and here we can observe chlorine uses -1 oxidation number. And in product side, also in zinc chloride, the chlorine is still -1 oxidation state. Okay, which means, and which means and here also two chlorine atom is present, which means zinc has to be have +2. Okay, zinc has to be have +2 charge, that means +2 oxidation state. Now the oxidation of zinc changes from 0 to, we can easily observe that, 0 to +2. So zinc is being oxidized, and by losing electrons, by losing 2 electrons. And so zinc, now hydrogen, for hydrogen, uh, we have to observe, to consider the hydrogen's oxidation state. For hydrogen changes from +1 to 0. Okay, +1 to 0. Hydrogen is in elemental form in product side. Okay, and so HCl as a substance is being reduced. Okay, here hydrogen is reduced, but hydrogen is part of the hydrogen portion. Hydrogen is the part of HCl. That's why we can say we would say the whole substance is being reduced. Okay, if you have to choose an answer on a multiple choice test, then you have to choose the whole substance as a oxidizing agent, or reducing agent, or as a oxidized substance or reduced substance. Okay, you would choose the whole substance. Okay, whole compound is being reduced or is being oxidized. And now the substance that is oxidized is the reducing agent. So zinc is reducing agent, and typically metals tend to be reducing agent. The substance that is reduced is the oxidizing agent. So HCl is the oxidizing agent here. And this is the common question that you might see on a typical chemistry exam. Okay, and this is very common questions for MCQ or CQ. And now this is the half reactions for these reactions. Okay, this is oxidation half reactions, and this is reduction half reactions. And now our next problem. Now let's try one more example for practice. And methane reacts with oxygen gas and it produces carbon dioxide gas and water. Okay, and now you have to identify the oxidation state of every element in this reaction and then find the substance that is oxidized and reduced, and identify also the oxidizing agent and the reducing agent. Okay, so let's identify the pure elements, which is only oxygen gas here. Okay, you can easily identify that. Here only oxygen is pure diatomic element. Okay, diatomic molecule, and mm, and this is going to be 0. That means the oxidation state of oxygen is here 0. And now we say that whenever the hydrogen is bonded with a non-metal, it is going to have +1 oxidation state. That means here we can observe that the oxidation state of hydrogen with non-metal carbon is +1. And now when oxygen is found in a compound, go for oxygen now. Oxygen is found in a compound, the oxidation state is -1. Okay, usually -1 in oxides, and it is oxide. So here the carbon dioxide is oxide. Here it is used -2 oxidation state, and except when it is bonded to fluorine or except in peroxides or superoxides, the oxidation state of oxygen is different. Okay, and whenever you hear the word oxide, the oxidation state of oxygen is always -2. If you hear the word peroxide, it is use -1 oxidation state, and if you hear the word superoxide, it is -half. That means it use the oxidation state of oxygen in any superoxide is -half. And now we have to find the oxidation state of carbon. Okay, okay, carbon, and so let's start with methane. Let's start with methane, and for methane, we have one carbon in methane and 4 hydrogen atoms, which has to add to make 0. Okay, and because methane is a neutral compound, it is neutral in charge. Now each hydrogen atom has an oxidation state +1, so therefore carbon has to have an oxidation state -4 in methane. Okay, -4 in methane. And now let's calculate the oxidation state of carbon in carbon dioxide. Okay, carbon dioxide, here in carbon dioxide, 1 carbon and 2 oxygen atom. You can observe that 1 carbon and 2 oxygen atoms, which equals in the charge of 0. Okay, because carbon dioxide is a neutral compound, and each oxygen atom has a charge of -2. So in this case, carbon is going to have an oxidation state +4. Okay, +4. So carbon changes from -4 to +4. Okay, carbon changes from -2, which is present in methane, then to +4 in carbon dioxide. Okay, and therefore the oxidation number of carbon is increasing. Okay, we can observe that the oxidation state of carbon is increasing, which means carbon is oxidized. Okay, carbon is oxidized, it loses electron, and there that means we can say methane is oxidized. Okay, as a whole substance. Okay, okay, we should say we should take the whole substance as a oxidized substance. That means methane is oxidized, and now hydrogen does not change, but oxygen, here you can observe hydrogen does not change. +1 here, +1 in product, +1 in methane, and +1 in water also. But oxygen uh, changes from 0 to, oxygen changes from 0 to -1. Okay, -1 also carbon dioxide, in carbon dioxide, and -1 also in water. And so for oxygen gas, the oxidation number is decreasing. Okay, the oxidation number is decreasing from 0 to -2, and that's why oxygen is reduced and it gains electrons. That means oxygen is reduced by gaining electrons, and it is the reduction half part of this whole reaction, of this redox reaction. And so uh, here methane is being the reducing agent, and it helps to reduce oxygen. Okay, it's methane is the reducing agent and it helps to reduce the oxygen. Okay, and oxygen gas is being reduced, which makes it the oxidizing agent. Since the oxygen is reduced here, that means it's the oxidizing agent. And now our this reaction has now, let's go for another reaction. This reaction has different elements, and the other important thing is here the elements are grouped together in compounds in reactant sites. Okay, it is nitric acid and hydrogen sulfide. Both elements, here the elements are grouped together in these two compounds, and so there is more than one element. That means we can easily observe that there is more than one element together in these compounds. And now we want to get oxidation numbers for all the elements. And okay, and for that we have to follow the rules for oxidation numbers, and these are the numbers. Okay, these are the oxidation numbers, and you can see. And now we want to look at the changes in oxidation number for each one of the elements. Now some of them are, you can easily observe that some of them are going to change, and some of them are not. Okay, and now let's look at the first reactant, nitric acid. Okay, nitric acid. And here we got at first we got hydrogen, and hydrogen here is +1. You can see +1, then and here it is a +1, and on the right side here also, in the second reactant, here also it +1, and on the right side it's also +1 in water, in this product. Okay, and okay, hydrogen's oxidation, that's why the hydrogen's oxidation number does not change at all. Okay, we can say the hydrogen's oxidation number does not change at all. So hydrogen's not getting oxidized and it's not getting reduced, so we don't have to worry about hydrogen's oxidation number, worry about hydrogen. Okay, now uh, now nitrogen, we look at this nitric acid. Here nitrogen is plus, you can see, +5. Okay, and then it's +2 over here in product, nitric oxide. Okay, in product it is +2. And okay, and so we can see a change in oxidation number for nitrogen, and it's going to down from +5 to +2. by gaining 3 electrons. So if the oxidation number goes down, it means it is getting reduced. So nitrogen is being reduced from +5 to +2 by gaining 3 electron, and then we can say this is the reduction reaction. And now now uh, we got the oxygen. Okay, this is oxygen. Hydrogen and nitrogen is done. So oxygen, and we got oxygen, it's -2. Okay, and here we can and on the right side it's -2. Okay, in nitric oxide, one of the product, and also in water are -2. Okay, so nothing changes with oxygen again. Okay, nothing changes with oxygen again, so we don't have to worry about oxygen. And then we have sulfur in our another reactant, hydrogen sulfide. Okay, and we have sulfur which is -2. We can observe which is -2 in this reactant, hydrogen sulfide, and on the right side we have sulfur which is 0, which this is elemental sulfur, and we know pure elements are um, have pure elements have 0 oxidation state, and so this is changing from -2 to 0. Okay, -2 to 0, and it's becoming less negative. That means it's becoming less negative. The oxidation number goes up, and which means that oxidation is taking place here. That means sulfur is oxidized, it loses electrons, and oxidation is taking place here. And so for uh, sulfur is being oxidized from -2 to 0. And now we have to understand another thing. The atoms that are getting oxidized and reduced, we have already discussed about that, but I repeat it. The atoms that are getting oxidized and reduced are the part of compounds with other elements. Okay, here sulfur is the part of hydrogen sulfide, and nitrogen is the part of nitrogen element is the part of nitric acid compound. Okay, now when we are talking about oxidizing agents and reducing agents and identifying them, we have to look at the whole compound. Okay, we have to look at the whole compound, and not only the atoms. Okay, not only the atoms, specific atom. Sulfur is losing electrons, but sulfur is part of hydrogen sulfide, and so hydrogen sulfide as a whole is losing electrons. And so we are going to say this is hydrogen sulfide reducing agent is the reducing agent, and hydrogen sulfides that's getting oxidized, it's losing electrons. This nitrogen atom is definitely getting reduced, but it's the part of nitric acid, so the whole nitric acid is gaining electrons. So we can say hydrogen sulfide is oxidized. As a whole, hydrogen sulfide is oxidized, and hydrogen sulfide is the reducing agent. And as a whole, nitric acid is reduced, not nitrogen is reduced. Okay, we have to say, we should have to say nitric oxide is reduced, and nitric oxide is the oxidizing agent. Okay, and now we can sum up this concept here with this simple diagram. Okay, with a with this simple diagram. Okay, and the sulfur from here, the sulfur from hydrogen sulfide is giving electrons to the nitrogen in nitric acid. Okay, and so now we have this information, and we can figure out the oxidizing agents and reducing agent easily. H2S is getting oxidized, it's giving electron to nitric acid and allowing nitric acid to gain those electrons, so it is allowing reduction to take place, and so it is the reducing agent. Hydrogen sulfide is the reducing agent because it is allowing reduction to take place, and that means the things that is oxidized is the reducing agent. And then here nitric oxide is reduced, it's taking electrons from hydrogen sulfide, which allows hydrogen sulfide to become oxidized, okay, and it allows it to lose those electrons, so that means that mm, mm, hydrogen sulfide is making oxidation happens, so nitric acid is the nitric acid is making oxidation happen, so nitric acid is the oxidizing agent. Okay, I think oxidizing agent, reducing agent, oxidized substance, reducing substance, reduced substance are all are clear to you. Okay, and it's very important concept in chemistry. And now so consider another reaction. Aluminium metal reacts with copper chloride to produce aluminium chloride and copper metal. Okay, now this reaction this reaction is redox reaction, you have to identify. Okay, so the reaction is a single replacement reaction. Okay, this reaction is single replacement reaction or single displacement reaction. Okay, and here copper is displaced by aluminium and produce aluminium chloride, a new compound. Okay, and then there is a transfer of electron. We can see here from the oxidation numbers, we can easily observe that aluminium has an oxidation state of 0 in reactants, and but in aluminium chloride it has an oxidation state of -3. Okay, and so if the oxidation number changes, then it's a redox reaction. All single displacement reactions are redox reactions. You have to remember, all single replacement reactions are redox reactions. Now if you don't want to look for the oxidation numbers, there is a quick way to tell. Okay, if the reaction is going to be a redox reaction, the reaction is going to be a redox reaction. If you see a pure element on one side and then that element being part of compound on the other side, it's always going to be a redox reaction. Okay, that means there is a transfer of electron. Okay, now here you can see aluminium is a pure element on the reactant side, and this aluminium be in product side being part of a compound which is aluminium chloride. Okay, on the other side, on the product side, so it is a redox reaction. Okay, it's an easy trick, it's a quick way to identify the redox and non-redox reactions, and this is the half reactions for these reactions. Okay, and now now let's take more two examples and determine if it's a redox reaction or not. And so both of these examples are synthesis reactions. Okay, and also known as combination or addition reactions. Sometimes a combination or addition reaction can be a redox reactions, and sometimes it won't be. Um, in redox reaction. Okay, and now if you look at the first reaction, this reaction, okay, for the first at the first example, if you look at the first example, there are no pure elements. You can observe that there are no pure element, all we have is compounds. Okay, magnesium oxide, water molecule, and magnesium hydroxide, all three are compounds. When we see that type of change, chances are it is not a redox reaction. Okay, but if you look at the second example, okay, we have a pure element zinc, okay, and then that same element is in a compound in product side, in a zinc chloride compound, part of a zinc chloride compound in product side. So the second example is redox reaction, and now let's prove it, okay, using oxidizing numbers, okay. And let's start with the first example, oxygen. Here you can observe the oxidation numbers here, and oxygen has a minus charge in magnesium oxide, and also and minus charge in water, that means reactants. And magnesium is magnesium in magnesium oxide has a +2 charge, and hydrogen has a +1 charge, okay. And now in magnesium hydroxide, okay, that means in products which is composed of magnesium plus 2 hydroxyl ions, okay, magnesium and 2 hydroxyl ions. And as you can see, magnesium still has an oxidation state +2 in magnesium hydroxide, and oxygen is still -2, and hydrogen is +1 in magnesium hydroxide. So notice that the oxidation state does not change for any element. That means there was no transfer of electrons, and so this is a non-redox reaction, okay. So this is not a redox reaction. Now let's analyze the second example, okay. And here zinc and chlorine has an oxidation state of 0 because they are pure element, and in reactant sites, and in zinc chloride the chlorine has -1 oxidation state, and zinc has +2 oxidation state. So notice that zinc is being oxidized here, and chlorine is being reduced here by gaining electrons, okay. And so this is a redox reaction, and zinc is reducing agent here, and chlorine is oxidizing agent is here. And now consider these two decomposition reactions, okay. One is this and one is this, okay. When mercury, the first one, when mercury oxidize is heat oxide is mercury oxide, okay. Mercury oxide is heated, it decomposes into mercury and pure mercury, metallic mercury, and oxygen gas, diatomic oxygen gas molecule. And if you were to heat calcium carbonate, for the second example, if we heat calcium carbonate, it will decompose into calcium oxide and carbon dioxide gas, okay. So which of these decomposition reactions is the redox reaction, okay. We know sometimes decomposition reactions are redox, sometimes not. And looking at the first examples, we have oxygen as a pure element on the right side, okay. Looking at the yes, this is the reaction, okay, and right side. And we have oxygen as the pure element in product side, and then that same element is within a compound in reactant side, okay. So the first example is not a redox reaction. This is the easy track to identify redox reaction. And in the second example here, no, there are no pure elements, okay. There are no pure elements, all we have just compounds, calcium carbonate, calcium oxide, carbon dioxide, all are compounds. So the second example is not a redox reaction. That's a quick way to tell it's a redox reaction or not. And you also you can prove it using oxidation number or oxidation state, okay. And this is pure elements, okay, this is redox reaction and this is non-redox reaction. Now I am going to give you a list of reactions, okay, list of reactions, and you have to identify which ones are redox and which ones are not, and try. Okay, and so the first example, let's try. The first example is the redox reaction, combustion reaction. It's a combustion reaction. We can see this is ethanol. Ethanol is the organic compound, organic alcohol. When ethanol burns in oxygen, produce carbon dioxide and water. And here we have a pure element on the reactant side, and then that same element is inside a compound on the product side. Okay, in carbon dioxide and also in water molecule. And so the first reaction example is the redox reaction. Okay, and what about the second reaction? And there are no pure elements in this example, so it is not a redox reaction. Okay, it is not a redox reaction. And usually and always acid base neutralization reactions are not redox reactions. Okay, and anytime when you have a double displacement reaction, is never going to redox reaction, is never going to be a redox reaction, but all single displacement reactions will be a redox reaction, and acid base reactions are double displacement reactions, so these are always non-redox reactions. Here sodium hydroxide is a base and HCl is a strong acid. They react with each other and produce sodium chloride salt and water. Here no electron transfer is occurred, and only ion exchange is occurred. Okay, and by exchanging ions and the reaction happens. Okay, and for now the third example is a combination reaction. Okay, carbon dioxide combined with water molecule produce carbonic acid, and there are no pure elements are present, and so therefore it is not going to be a redox reaction. The last and so it is a non-redox reaction. And now especially the third one and the last one is a double displacement reaction. Okay, silver nitrate so reacts with sodium chloride and produce insoluble silver chloride, which settles in at the bottom of the container, and soluble sodium nitrate solution. Okay, and especially this is a precipitation reaction, and especially a precipitation reaction um, is always is always a non-redox reactions. Okay, this is also happened by exchanging ions. Okay, and here we can observe that silver and sodium ions and silver ions exchange their positions and produce new two compounds. Okay, and in this reaction all four we have are just compounds, and this is a precipitate reaction and non-redox reaction. And so to review, all combustion reactions are redox reactions. Okay, you have to remember this. All single displacement reactions are redox reactions. Okay, now synthesis and combination reactions, sometimes the redox reactions and sometimes not. Okay, and the same is true for decomposition reactions, and double displacement reactions are never redox reactions, so that includes these includes acid base neutralization reactions, precipitation reactions, and other types of double displacement reactions. And a quick way to tell is, if you see a pure element on site and then the same element within a compound on the other side, it's going to be a redox reaction. Okay, and students, that's all for today. Assalamu alaikum.